Here we have a problem that's asking us which of the following is the solution to the differential equation. And then they give us this scary looking derivative here, dy dx equals this huge equation. And it also has to contain this point 0, 3. The first thing that we've got to know is sort of what does it mean for something to be the solution to a differential equation? Differential equation, that word always seems to freak people out. I think they hear a lot of crazy math talk about differential equations, and so they think this has to be a very complex problem, especially when you look at what that derivative or that differential equation is. Well, to be the solution to a differential equation means that the derivative to a function, dy dx, that's what a differential equation is. That's just fancy math talk for a derivative, has to fit this little formula over here. And so what we're really being asked on this problem is, of all of our answers down below, which of them would fit that same derivative when we get done with the whole thing? And so what you really are being asked to do on this is to go through and find the derivative. This doesn't sound much better, but it's not that bad. The derivative to all these different equations here, and see which one of those, if you took the derivative of it, you could make fit this definition, this dy dx that they give us here. So what we're going to end up doing is taking a lot of derivatives until we find the one that fits that. Again, the classic AP Calc question where you've got 5 little questions inside of one question. The first thing you want to do, so we'll look at A here to begin with, and we're trying to figure out if this equation, if I took the derivative of it, would end up fitting this definition that they want us to fit. That's a solution to that differential equation. When they give you a point to work with, the first thing you want to do is just make sure that that point works with the equation you're working with. So when I plug in 0 for x, I need the y value to come out of there to be 3. Sometimes you can just avoid having to take the derivative by doing a little plug and chug and see what goes on. So here I would come in and I would plug in 0 for x. I'd get e to the 0. Anything to the 0 power is 1, so I would have 1 plus 2 equals 3. So that tells me that it's worth my time now to go ahead and take the derivative of this because I know for sure it at least has this point on it. So we come in and we take a derivative of this function. So y equals e to the x squared plus 2. Working through this, the derivative of e to the x squared, that's going to end up being a chain rule. So we've got a function inside another function right there. We have an x squared plugged into the e function. So my saying for the chain rule goes d in times d out. The derivative of whatever is inside the function times the derivative of that outside function. So if I come through here and I say, okay, dy dx equals the derivative of the derivative of x squared following our power rule, bring the power down, subtract 1 from the power, gets us 2x. And then the derivative of the outside on an e, that's one of those special case derivatives. E is a special case. You just have to know it when you see it. If you don't just know it, you're probably not going to guess it. So if f of x is e to the x, the derivative of e to the x is e to the x. So the derivative of the outside on this is going to stay the exact same. So this would be e to the x squared. That's our d out. Then moving over to the right, the derivative of 2 is a constant. And so the derivative of 2 would just go away. So now what we have to do is we have to say, does our little derivative right here fit that derivative equation that they started us with? So if I plug in all my pieces into that starting derivative, do I end up getting back what I just ended up having? And so to do this, you would say, okay, dy dx equals 2x. And now when they talk about y is that original equation. Y is equal to e to the x squared plus 2. So you plug in for the y, e to the x squared plus 2 over x squared plus 3. And can that derivative now be simplified to look like what we got out? If so, then what we got out, then what we started with is a solution. And you can see there's really nothing you can do here. There's no cancellation. Nothing's going to go any further. And this definitely does not match the derivative that we just got out. So A is now off the table. And so here we go, continuing on down our road, we'll look at b now. So we get y equals the natural log of x squared plus 3x plus 1. Again, start off here by plugging in 0 to the equation and seeing if we get out 3 as an answer. So if I plug in 0, I get the natural log of 0 squared plus 3 times 0 plus 1. That's going to equal the natural log. We get 0, 0, so this would be the natural log of 1. The natural log of 1 is something they want you to know. The natural log of 1 is equal to 0. And so what we can see is we didn't get out the y value of 3. So we know that that can't even be an option right now because it doesn't even contain the point that we're looking for. So the lucky part about that is we don't have to take the derivative. We know that couldn't be the answer because it doesn't contain the point that they told us it has to contain. So now we're going to look at c. So we start off with c and we get y equals x squared plus 3. Go through our process. Let's go ahead and plug in 0 for x and see if we get out 3 for our answer. So we get y equals 0 squared plus 3. So y equals 3. Okay, so check. We have this point on our graph. So we know that it contains that point. Now we go through the process of taking our derivative. So y equals x squared plus 3. Finding the derivative of that, our dy dx would equal 2x. Doing our power rule. Bring the power down, subtract 1 from the power, and then the derivative of 3, a constant, goes away. Now we want to go back to our differential equation they started us with and see if we plug in everything, if it all simplifies down to being our derivative. And if so, we have a solution. So we would get 2x. This time, instead of y inside there, we're going to plug in our y equation, which is x squared plus 3. And then that's all over x squared plus 3. This time what we'll see is conveniently we've got an x squared plus 3 on top and an x squared plus 3 on bottom. And when we simplify that down, we see that we get dy dx equals 2x. Our two pieces match, our two derivatives match each other. So yes, indeed, y equals x squared plus 3 is a solution to this differential equation. And we're done at that point. If you weren't done, you would just continue the process through the rest of them until you found which one of them made this little game work. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.